Okay, our next company is Altech Batteries Limited. Altech has a ASX code ATC. It has a market cap of approximately 110 million. Altech Batteries Limited is a specialty battery technology company that has a joint venture agreement with world-leading German battery institute, IKTS, to commercialise the revolutionary CERENERGY sodium chloride solid-state battery. Presenting today is Managing Director Iggy Tan. Iggy, welcome back to the network. Please take it away.
Thank you. You probably woke up this morning wondering what is the future of grid storage batteries. So let's start the video. So one of the challenges of lithium-ion batteries is obviously battery fires. And the reason of that is there's a flammable liquid electrolyte in lithium batteries, and that's why the industry is trying to move to solid-state technology. So in a lithium-ion battery fire, it actually generates oxygen at the cathode end of the battery. A lot of people also don't realize that lithium batteries only operate in a limited temperature range. So when you are at 0 degrees, your battery capacity drops to 70%. So it's very limited range when you get to very cold temperatures, and also in very hot climates. So as you know, in a Tesla battery pack, there are 26 cooling fans. So about 30% of your energy is to keep the batteries cool. So that's one of the limitations. Of course, lithium is another important consideration. We saw the price hikes of lithium. It's a critical mineral that the industry is concerned about. The other critical element is graphite. China provides 90% of graphite around the world, and that represents a geopolitical risk. So one country producing 90% of materials. The other material is cobalt. 70% of cobalt is produced in the Republic of Congo, and the industry is concerned about ethical supply because you have child labor issues and so on. And then the other component is also copper. Copper represents a big component in the battery. So could you have a battery that uses just common table salt? And introducing you to the CERENERGY battery, which was developed by the Fraunhofer Institute in Germany. And this is what the batteries look like. They're essentially a solid-state technology. It uses a ceramic tube, and it uses sodium chloride as well as nickel metal powder. As you can see here is a 5 kilowatt battery, and it uses common table salt. That's essentially what the battery looks like. It's a ceramic tube in a metal cylinder. These cells are about 240 watts. And as you can see here, a vision of some of these batteries undergoing tests. If you take a cross-section, this is a 5 kilowatt battery. It's fully insulated, and essentially it's a hot battery. So how does the technology work? So your ceramic tube, as you can see on your screen here, in the middle of the tube is a positive terminal. We fill it up with sodium chloride or common table salt and nickel metal powder. And you can see the picture of that ceramic tube there. This tube then sits in a metal canister, which acts as the negative part of the battery. So as you can see, just pure metal stainless steel canister, and you can see the picture across here. And as I said, these cells are about 250 watts. Now the chemistry is very simple. When you charge the battery, sodium ions migrate through the ceramic bit, which is the solid state, and it forms molten sodium on the other side of it. So there's no actual anodes. It's a self-forming anode. The reason the nickel is there is it grabs the chloride and allows the sodium to migrate. If you take a cross-section of the battery, you can see the molten sodium forming on the inside. So what's unique about this battery, it's a self-forming anode. When you charge the battery, it forms the anode. And when you discharge the battery, it dissolves the anode. Now you can see the battery being discharged. Sodium ions then migrate back through the solid state, grabs the chloride, and becomes salt again. So very unique chemistry. and it was developed by the Fraunhofer Institute of Germany. They've spent nearly 30 million euros developing the technology. The chemistry has been around since the 90s, but their technology is about getting a bigger battery for the grid storage market. Now, the exciting part of this is not a research and development project. All the work has been done, and we're essentially commercializing this technology, and we're building a first plant, which is 120 megawatts in Germany. Here you can see some of the vision of the pilot plant. You can see some of the aluminum being mixed up to make the ceramic tube. Of course, in the ceramic tube, there's a lot of technology and different components that allow the sodium ions to migrate across. You can see these tubes being made, and this is a 10 kilowatt battery. And here you have a cross section of one of these batteries. So they're essentially fully insulated. You can touch it on the outside, but essentially these batteries operate around 270 degrees on the inside. What's great about it, there's no cooling fans on these batteries. It looks after its own temperature, because when you charge the battery, it's exothermic. When you discharge, it's endothermic. The project itself is in Saxony, Germany, essentially right on the border of the Czech Republic. And Saxony is a very exciting state. There's a lot of developments in EVs and battery plants. And here you can see some of the vision of our proposed factory. 120 megawatts, and of course we use renewable energy to power the plant. We are in the process of producing two 60 kilowatt prototypes. So our basic battery now is 60 kilowatts. We don't make the smaller batteries at all. Here you can see some of the aluminum being mixed up, being slurried up. That has to be dried in a flash dryer. And this material is then made into ceramic tubes, which then has to be sintered at 1600 degrees over 36 hours. So that's part of the technology, making these solid state ceramic tubes. Here, the ceramic tubes are undergoing some quality checks, so to make sure there are no cracks. Here's the vision of the ceramic tubes going into the metal cylinders that act as the negative part of the battery. And from here, we add the sodium chloride and nickel metal powder as granules. These are loaded up into the batteries. And then the positive probe goes in, and then they're welded together so they're pressure tight. So essentially these cells, you can see here, undergoing some tests under temperature. And they all, 240 of these cells go into a bigger battery, which we call our 60 kilowatt battery. So 60 kilowatts running at about 600 volts, 100 amps. And essentially this is our basic model. What we are going to do is put this into grid packs for the grid storage markets. Let me explain to you what the grid storage market is. Essentially, we have a lot of solar farms and wind farms generating electricity. Unfortunately, during the day, there's not a lot of demand because households are also generating their power. And in countries like Germany and California, nearly $3 billion worth of renewable energy is actually discharged to the ground during the day because it can't be used. Now, of course, when cloud cover comes or nighttime, or of course, when EV comes online, there's got to be a solution for that. And essentially, the solution for these problems is grid storage batteries. So essentially, what it is a very big battery, or a whole stack of very big batteries sitting on the grid. So during the day, when the sun and the wind farms are operating, these batteries are being charged up. And the power of these batteries can also charge EVs. So if you have EV charging stations, these are ideal for those stations, because there's no way you are going to be able to take that from the grid during the day. And our basic product is actually a 1 megawatt grid pack. So we've got 1 megawatt fully installed, very easy to ship and install by just dropping it on deck and plug and play. You have 1 megawatt connected to your grid within 5 minutes of delivery. So this is a big advantage. And the fact that we don't have any cooling fans, we don't have to service these grid packs, they can actually be stacked one on top of the other. So the footprint of these storage batteries are minimal. We are in the final stages of a DFS for the 120 megawatt plant. As you can see, this is some of the design of the factory. We have to produce one of these cells every 45 seconds. So you can imagine that we have to use a lot of automation and robotics. And obviously, Germany is a great place for that. The auto industry is well developed and mature, and we're capturing a lot of the supplies for the auto industry in this battery plant that we're proposing. So essentially, that's our project. 120 megawatts of sodium chloride solid-state batteries, essentially for the grid storage market. The grid storage market is growing at 28% year on year. And in fact, Elon Musk has even said the future growth of their battery business will be from the grid storage sector. So thank you very much, and I welcome any questions.
Thank you, Iggy. That was great. Okay, just a couple of questions for you. But perhaps if you could sort of give us an idea of what we can expect in terms of news flow over the next few months, and specifically, when do you think we're going to hear about the finalization of the prototypes?
Yeah, well, the prototype will be in the next 6 months. They will go into the industry to undergo performance testing. Our next milestone is the launch, the release of the definitive feasibility study. We have essentially completed all the work. It's just we're now going through the optimization process. There will be news on application for the project, environmental application. So we'll commence the application process. Of course, news flow on funding of the project. We are talking to European banks, and we are also in application for grants. As you know, a bit like the IRA, the European Union has also very similar grants, and they're looking to support some of these energy transition projects. So very exciting news going forward.
Okay. And can I ask you, what's the status of negotiations with potential customers? Are you having quite a few sort of discussions with potential customers?
Yeah, great question. So we are in final discussions with 1 or 2 utility suppliers. One of those utility suppliers have plans to put 8 gigawatts of renewable energy power. They're actually a electricity provider using brown coal, and the EU has given them billions of dollars to swap away from brown coal. So they are looking to go to renewable energy supply, and they need batteries. They're interested in our batteries. They will use lithium-ion batteries. They'll use redox flow batteries. But all kinds of batteries have a place in the future world of grid storage.
Okay, great. And one last question before you go. What is the status of prototype materials procurement? Have you've got everything you need? Are you finding any difficulties in procuring the materials required for the prototypes? Are there any challenges?
We've purchased all the materials. We're about halfway through the production of these cells. The final casing has already been delivered. So essentially, prototype is well underway.
Okay, great. Iggy, thank you very much for your time today. We look forward to seeing you back again soon with some further updates, but it seems to be going very well. Have a great weekend, and we'll see you back soon.